Now, the last topic in this lecture, or this module, is configuration management. So we'll talk about configuration management for a bit. In this, I'll define what I mean by configuration management. I'll have a look at the configuration management process that is used in ISO 15288, which is a system development process standard. And we'll have a look at the contribution of configuration management to quality. So we'll start with the question about what is configuration management. Well, largely it's a practice that ensures that related changes across several components are implemented together. So it keeps things that are related to the one change together. Now, in fields other than software, one example might be that if you change a component on the motor of a car, for example, and this causes some switch in the electrics, so with that particular component you need this type of fuse and you need this type of something else. It ensures that all these things are done at the same time, and the related changes are kept together. This is because changes are not necessarily self-contained. There are dependencies across different parts of the system. And so configuration management largely ensures that those things that need to be changed or implemented together are done together. Now, in practice, there are several practices of configuration management. The first of them is to handle changes systematically. So changes, you can keep track of all the dependencies, what depends on what, and if you change this thing, where are the changes impacted, and what are the related changes that you make. Configuration management can enforce different policies that you may want to have enforced. At the moment I can't think of any particular policies, but I understand this is what happens. But more particularly, so far as software development is concerned, configuration management keeps track of dependencies between different parts, different components in the system. In ISO 15288, now ISO 15288 is the systems engineering lifecycle processes. Now, systems engineering, largely, I guess you'd associate that with the military. The processes are supposedly all of those processes that you are likely to need in order to make a software system. Among them is the configuration management process. Now, it has, among other things, a definition of its purpose, which is to establish and maintain the integrity of all outputs and to make them available to people to obviously intend to be available. There are various outcomes called in these processes. They're defined in terms of a purpose and outcomes that show that purpose is being achieved. The outcomes that 15288 talks about is that a configuration management strategy is defined. So there's some sort of a strategy defined that controls how the configuration management is used. Items requiring configuration management are defined. So you define what has to be managed. A configuration baseline is established. Okay, so you get a baseline of a system that works and the dependencies between all that part of the system. Changes to items are controlled. So you can't make just any change. The change is tracked, and the new version of something is kept track of and made available. The configuration of releases is controlled. So the releases coming out of that repository of managed items is controlled so that you get what you are intended to get and nothing different, nothing else. And the status of items within the repository is known and made available to anybody who wants. So one of the things that is fairly essential to configuration management is some kind of an audit function so that you can tell what's there and what the state of it is. Because you could have something that's in there that is actually not operational. there's been a change made which is broken, and you shouldn't use that one. If you need to do something, then you should use the prior version of it, and all that matters in all of its dependencies. Now, the contribution of configuration management to quality was mostly to keep track of things. A large problem in software development from prior to when configuration management was used was that the wrong versions of things kept being incorporated. So somebody might come along and fix a bug and create a new file. Someone else might not know that that new file has the bug fixed, and so they pick up the old file, or they pick up the new file, but not all the other files that are dependent on it. And you get systems built with half the files, half of the changes implemented and the other half was not, and you've got bugs, and you've got bugs kept coming back because the new files weren't picked up and the new versions weren't picked up, and it just becomes somewhat chaotic. With you implement configuration management, the whole idea is to avoid all that, and because it rather enforces the discipline that you configure all the changes and the dependencies when you have time to think about it. Trying to put together a release is not a time when you have time to think about it, so it's not a good idea to do it. Now, configuration management in software development is the new normal. It's expected. It's professional practice. To not use configuration management in a software development project of even a small size is probably equivalent to professional misconduct. You should not do it. So in summary then, configuration management manages the dependencies between components of a software system and manages changes to those components of the software system. It is, as I said, now expected professional practice. So with that, we've completed this module on automation in software development.